All right. So this week I want to present another tip of the week. This is inspired by some of the questions that came up, what actually Pythonic programming is. And at least what I'm showing you today is one way how you can program more Pythonic. And I'm not being very explicit in the definition of the word Pythonic, but I will give you a definition a bit later on. But so what I'm going to tell you now is a concept called list comprehension, and it's very, very useful. So there's a very I have a very simple program, a task here. I have a bunch of names, and what I want to do is I want to create a new list that contains a greeting plus the name. So essentially I want to have a list where it says, hello Sam, hello Marie, hello David. Right? So a C programmer, right, would do following. He would write a list. He would write a loop for I in range. Right? So we need to loop over all the indices of the names. So we can check them. We can use this range function to give us a list of all the length with all the numbers starting from 0 all the way to the length of the names minus 1. So now we have the index. And so now what we can do is we can we can say greetings okay, so this doesn't exist, so I just maybe fill this with nones. We need 3 nones here, and we can say, okay, this is equal to okay, this is to hello, and then we have a placeholder here, format, and then we say names of I. Okay, and so that's it, and so we can then do print greetings. Okay, so that's, we can try it out. We get hello Sam, hello Marie, hello David. So it works. So there's a few things. This is a bit not very readable, right? Because we have to create these indices here, and so it would be nice if we don't need them. And so in Python, right, we typically don't loop over indices, but we loop over the objects, the items in the list itself. So the first simplification that we can do is we say for name in names, right? And so then, of course, I don't have the index here anymore. So then typically what I would do is I would start with an empty list here. And because I know I can append stuff to a list, I would greetings.append. And what do I want to append? Hello. And then my placeholder again. And then the name. Okay? So now essentially I start with an empty list. I loop over all the items in the names and start appending to the greetings list. And so that should give the same result. And so now we've already kind of got rid of the indices. But there's an even nicer way of writing this, and we can write this in one line essentially. And that's called list comprehension. So the way this works is that we can an equivalent code of the 2 lines above of this for loop here is to write greetings equals. And so now I will have now a statement, and that statement I want to execute for each name in names. And so what this does is it loops over all the items in names and does something with the item that I still need to specify, and stores the output into a new list. So we take in a list, we perform element-wise an operation, which is this XXX here, and then we get a new list out. And so here what I want is, of course, I want hello, same thing, dot format name. Okay, and so now I can remove this. So now, and this is what's called a list comprehension. We take in a list and we generate a new list by performing an operation element-wise on it. And it's quite natural. Once you get used to the syntax, it's very natural to read this, and it's very natural to think about how to perform certain tasks using list comprehensions. You can just check that it runs. Yeah, you get the same output. And so the same thing actually also works if you, so list comprehensions are, you have a list and you want to generate a new list. The same thing also works if you have dictionaries. So let's say we now have not just the names, but we also have a associated phone number to that name. And so maybe that's +47 something. So I use tuples here now, because for every name, I now also have a phone number. And then for the second name here, I also have a phone number. And then let's get rid of the third name. Okay? So now, okay, so if I have this structure, and let's say I want to create a dictionary that maps the name to the phone number. So now, of course, I could do the same thing, right? I could loop over all these items and create I could start kind of with this is my phone book. And a phone book is a very classical example of a dictionary because it maps you can use this structure to map, for instance, names to phone numbers. And so now I could, of course, loop over the names and start adding these names into the dictionary in a for loop. But again, there's a faster way of writing this using a dictionary comprehension. And it's very similar to the list comprehension. It's here I have key value and then for key value in the original list here, right? So this now, it takes a list, my names here, which consists of tuples. And these tuples I interpret as the key value items for the dictionary. And this is how I store it. So in my case, right here, this would be my tuples in the names list here consists of name and number. And so here, for instance, I use a very simple mapping. So maybe you want to say, you want to add something, you and number. Yeah, whatever. Number. Format. So now we actually change also the items. Okay, but so now the output, this phone book now, will be a dictionary of with all the names as indices and the associated phone numbers as items. So we can test this out. Right? And so you can see these curly brackets, they indicate that we have a dictionary, and then here are the phone numbers. And now you can see that the items I've added this word number here in front of it, so you can also change the items. So let's say, maybe we want to, let's get rid of this again. Right, so here now we create a mapping from the name to the numbers, but we could have just as well created a mapping from the number to the names. Right? And so now this phone book would be an inverse phone book where I could ask for, okay, maybe I have this phone number here, and then this would give me the actual name of that. So this would now give me Sam. Okay? So knowing kind of these both dictionary conventions is a bit more advanced, but list comprehension is really something that you will see a lot in other people's code, and it's something that you should absolutely be using if you work with lists. Yeah, and so then there's also one Easter egg in Python. So if you're in IPython and you want to know what Pythonic programming is, you can write import this. If you, oh, it doesn't actually do anything. I think I need to restart. There we go. And so this gives you, this is an Easter egg in Python, and it tells you how you should program. So this is the Zen of Python. It's a short, what is it called? Not a novel, but yeah, a short piece of text that tells you how you should program, how you should prioritize where you program. And I won't go through that, but if you want, you can read it once. So essentially, it tells you should, of course, you should more beautiful code than ugly. Remember, this was the exercise that I gave you last assignment. Then explicit is better than implicit. Simple is better than complex. So saying, essentially, sometimes it's better to have a little bit more code, but then have it relatively simple rather than having it very, very compactly and very, very complex. Right? But anyway, so I guess Pythonic style follows these rules. But of course, they're not very explicit, so this is something one needs to learn over time. And list comprehension is one of these tools that allow you to be more Pythonic. Any questions regarding list comprehensions? No. So then let's continue with regular expressions. So we stopped at these quantifiers that allowed us to repeat characters. So the next thing I want to show you is the following problem. Let's say we have a long string consisting of loads of pineapples, and we want to match all the apples in there. There's a lot of apples in there, and we want to match all of them. So my first idea was that we created regex, and we say, okay, we have an apple, and it's followed by some word characters in here. The problem now is, if you execute this, you actually only, let me just clear this, you actually only get one match. You get this really long word as a single match. But I wanted to have these words separately. Right? I mean, so, and the problem is that regular expression is greedy by default. So what you're specifying here, it's trying to get as many word characters as possible followed by an apple. And so, of course, all these guys here are word characters, and at the very end, there's the apple that I'm going to match. So this is different if I had white spaces in here, right? If I had apple and pineapple here, if I had it like this, then I would get a nice list of all the individual items, because the white space is not a word character. But if I now want to have the same thing, but like this, now it doesn't work anymore. So what to do? And the answer is that we need to do non-greedy matching. So we need to tell our regular expression engine that we are looking for the smallest instance that matches, not the biggest instance that matches. And the way you do that is, again, through a special notation. And the special notation is a question mark. In that question mark, we can add after any quantifier or character symbol. And by adding the question mark, it makes a greedy operator and non-greedy operator. So for instance, yeah, so we can use it for the plus, the star, and even the question mark. So remember, question mark as a quantifier was 0, 1, and then question mark becomes the non-greedy version of that. So keep in mind here that question marks now have a double meaning. If they just appear alone in front of a word, for instance, then it becomes just a 0 or 1. While if you have it in front of a quantifier, it becomes the non-greedy version of it. So how can we make use of this now to solve our pineapple problem? Well, we have the star operator, which currently tries to match as many word characters as possible. But now, if we change this to match as few word characters as possible, then things are going to be different, right? Because then what we're going starting from the left, we're trying to match word characters as little as possible until we hit the word apple, and then we stop. So then we will get pineapple. And so then we start again here, right? And we have word characters again. In this case, there's actually none, because we immediately get apple again. So then that we're also happy with. But we're stopping again because we're non-greedy. And then finally, there's pineapple, which are non-word characters, and followed by the apple. So now, hopefully, if I run this, probably run the right one. So now, in the non-greedy version, I get the pineapple and the pineapple as separated items. So this is important to remember, that by default, regular expressions are greedy. They're trying to match as much as possible, and you can use the question mark symbol to make it non-greedy. Right, next challenge, and next thing to learn. Now we're going to learn groups. So consider the following task. We want to identify all the prefixes in a text. So we're interested in this. We have a prefix, infix, postfix, and quickfix. And we're interested in these words pre, in, post, and quick. And so so our first guess would be that we're writing a regular expression that matches simply fix. So let's see what happens there. Oh, I want okay. So in this case, I get fix, 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 but I don't actually get the information that I want, because I'm interested in the prefixes. So of course, then what we could do is we could say, well, we add some arbitrary many word characters in front of it. So we say \w star fix, right? So then hopefully we get indeed the entire words, prefix, infix, postfix, quickfix, and there's one last one here. It's not shown, just fix. But that's not what I want, because I'm only interested in the prefix. I'm not interested in the full words. I'm only interested in the part that comes before. And so if you have a regular expression and you're only interested in certain parts of it, you can use groups to extract the information that you're interested in. And the way you do that is that you add brackets around the part that you're interested in. So if I open a round bracket here and close it here, I'm creating a group that tells me, please match words of that structure, but only give me the part that is marked by the brackets. So now, if we run this program again, I indeed only get the prefixes. And so note, in particular, if I just run this again, note in particular that there's an empty string at the end. And that empty string is, if we look at the full string here, we can see that there was just a word fix here without any prefix, right? And so that's where, in this case, we just get an empty prefix. Okay? And so, of course, we could also say, maybe we also want to include the F character, right? And then we get the prefix plus the F, and so on and so forth. Okay. So this even works if you have multiple of these. You can create multiple groups. So for instance, here we have an example where we have prefixes and postfixes. And we want to extract the prefixes and the postfixes at the same time. So what we do is we say I have one group here and another group at the end. One group at the beginning and one group at the end. And the group at the beginning consists of arbitrary word characters, and the group at the end also consists of arbitrary word characters. Okay, and so now we have two groups, and if we run this, we now get again a list of all the results, but because we have now two groups, we get actually tuples of size 2. And the first item of the tuple represents the results of the first group. In this case, it's going to be the prefixes. And the second item in that tuple represents the result of the second group. In this case, the postfixes. And so for prefix, we have pre and then an empty postfix. And for the word postfix, we get an empty string as a prefix and post as the result of the second group. So now we can start doing more advanced stuff with groups. We can start replacing specific parts in a text. And so for instance, here our task is we have a string, some source code for instance, and we want to replace all the word fix with breaks. Okay? And so of course, again, the simplest example is, well, a simple replacing task that we've done all the time, right? We could say, I just say my regex input is fix, my regex output is break, and then I use the subfunction to replace it. So I replace all the occurrences of fix with break. So that will also work fairly well, but there are some special cases. So here, prefix becomes pre-break, infix becomes in-break, and so on. But there's a special case at the end here where we have fix-fix. And so here, well, we argue that fix is maybe the, or we could call it prefix-fix, right? And so I want to keep the prefix, and I only want to replace the second fix with break. But of course, if I do the simple replacement, I got pre-break break, which is not what I want. So now I need to be more clever. So what I can do is I can create a group here that identifies the prefixes. And so this is my group here consists of a bunch of character classes, character instances. And these are the ones that I want to match. And so now, well, in fact, I want to replace the fix, right? So I'm going to do this. I'm going to match the fix part. No, sorry, it's different. I want to match this one. This part, the prefix. And now what I can do is I can back reference in the substitution text, I can back reference to the groups. And I do this by backslash and the number of the group that occurs. So because I only have one group here, it's going to be \1. So what's going on here is I'm interested in some word characters which are going to the prefix, followed by the word fix. But I want to remember the characters in the prefix. And then I want to replace this with whatever the prefix was, followed by the word break. Okay? So now this solution does indeed what we want. So it remembers the prefixes and replaces the fixed part with break. And this also now works for the last special case where we had prefix fix. So we keep the entire prefix as it is and only replace the break part. So this back referencing also works if we have multiple groups. So in this example, stupid example, I just want to replace funny and bunny, the two words. So what I do is I create two groups. One matches on the word funny and the other word matches on the word bunny. And then I can back reference to them. And I just swap the order. So I just say the match of the second match comes first, and then the first group match comes second in the output. And so we can run this. And you see indeed the text is swapped. Yeah?
How do you get it to do the whole group 0? Because when I just do /0, it doesn't give out the whole group.
Yeah, so the \0 is a special case that should match the entire group. So this, yeah. You know, I'm not sure. I need to check that. Yeah. So there's probably a flag that is missing for it to do that. Yeah. Okay. So here's a more complicated example where the task is we have this long string here, mo ha 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 hey, and we want to remove all the ha's in the middle. So there's a lot of HA, and we want to remove them. So the way we do that is shown here. So we're going to match a bunch of word characters, and we have to do that now in a non-greedy way. So we have a bunch of word characters, and these are supposed to match M and MO. And then we have a bunch of HAs that might be repeated many, many times. And that we want to do in a greedy way, so we want to match as many as possible. And at the end, we have again, word characters, as many as we want, but in a non-greedy way. So essentially, the important part is that these HA here are greedy because we want to remove as many HAs as we possibly can. And we group all of them, all three parts, so the kind of the first section, then the second section, and then the last section. And now, because we have three groups, we want to back references, and we only want to keep the first MO and the HE at the end, and we actually swap it here. So we say the result should be 3, 1. So if I run this, I've messed it up. Okay, here we go. We only get the MO-HE part, so we removed all the inner parts. But sometimes it's often useful. So these back references, they're limited. We only have 10 of them. And it's good practice if you don't use a back reference, then what you can do is you can tell the regular expression that that's a group here. This HA is a group because it couples the word H and A, and we want to repeat that as many times as possible. But we're actually not interested, we're not back referencing to that group later on again. We never make use of it. So that one you can do is you can add this special character. Oh, they haven't been swapped. Yeah, that's true. What happened? Right. Okay, so let me just finish this argument. So by adding this question mark colon, what you do is you tell the regular expression that you want to consider this as this HA as a group that can be repeated many, many times, but I'm actually not interested in referencing it. So don't count it in the back referencing. And so now this 3 becomes a 2, because I don't have a 3 anymore, because I don't consider this as a captured group. So now when I use 3 and I run the program, I got an error invalid group reference, because 3 didn't exist anymore. So I need to replace it with 1. But so there's an interesting point here that this seems to be, so something is strange here. It doesn't matter which. Oh, that's unexpected. Well, let's try and replace this with just, let's see what happens here. So this works. Uh-huh. Uh-huh. Okay, there's clearly something that anyone got an idea? No? Okay, I'll come back to that. I don't understand it. Yeah, good question. Okay. So to finish off, I wanted to show you a bit more of a complex example. And that example consists of matching IP addresses. So IP addresses are a sequence of numbers, and they essentially look like this. So these are all more or less valid IP addresses, so they're just a bunch of numbers, and they could separate by a dot, but they have to be exactly 4 numbers. So for instance, 127.001 is a valid one. But here the next one, this one has 5 numbers, 127.001. So that's an invalid one. Also here I messed it up because I don't have a number between this second and the third dot. So that's also an invalid one. That here is an invalid one, 4 digits, and I just have multiple zeros, but that's fine. This one is an invalid one because the numbers may only go up to 255. So that would be an invalid one. That would also be an invalid one. And so now the task is, can we write a regular expression that identifies which ones are valid and which ones are not valid? And well, I'm using this doc test that Jonathan presented last time. So I've written down here, this is the code that is being executed inside the documentation with these symbols representing code. And then the last line here represents the expected result. So I call this function isValidIP that takes in one of these IP addresses and is supposed to either return if it's a valid IP address or not. And so our task is now to write the regular expression that matches this. Uh-huh. second. Okay, so the first idea that we have is that, so we know a lot of things now. So what we can do, the first thing that we can do is we can say, okay, our regular expression obviously consists of 3 numbers, followed by 3 numbers, followed by 3 numbers, followed by 3 numbers. Okay? So that should be a good first start. So we can do pi 06 validate IP. And we
missing a statement in the document because you have 6 tests and only 5 results.
Right.
And I think
Right. Yeah. Thanks. Let's remove one of them.
But then shouldn't also it should be true, false, false, true, or
Yeah.
I'm not sure. Yeah.
So true. This should be definitely false. This should be false. The next one should be true. The next one should be false. Yeah. Okay. So we. No, the last one. So this is what I got. I got true, true.
Yeah, but why is the last one false in that case?
Oh, because the IP address can only go up to 255. Yeah, but we don't handle that yet. But so the point here now is that we match. Right, we match the last 2. We don't handle this special case yet, so let's just mark this as true for now, because this becomes more complicated. We want to handle the numbers as well. But at least now we match the case where we have 3 digits. Okay. So now the problem is that okay, so we can. This is a bit lengthy to write. So what we can do is we can just say we have a character equals. So this is the character that we want, and then we can write a little loop. So we have dots, and then I use the join operator to essentially generate the string that I just had. So I'm expecting 3 characters, and then I want to, I hope this works now. So I have, this is going to be, oh yeah, it's just the character 3 times, and then I want to join that 4 times. So that should give the same result. Yeah. Okay, so that's the same string now, just generated programmatically. So now the problem is that, okay, so this, okay, so then the first thing that we can do is we can say, maybe this actually occurs, it's actually sufficient if the, okay, maybe I should, this is a bit messy. Let's go back. Okay, so of course what we can say here is that the digits don't necessarily need to occur 3 times, right? So they need to at least occur once, or potentially more. So then what I can do this, right? And so now I'm already a lot closer. So this is now the only one that I don't match, and that I get incorrectly. True, this is correct. This one is the only one that I don't get correctly, because this one has 5 digits. But I still match it because there's 4. 4 digits will match the 5 digits, the first 5, sorry. These 4 digits will match the first 4 digits in this line, so this will be the match. So what I can do is I can now add my line end and line end characters to specify that the line has to start followed by 4 of these patterns and then end again. So then I don't allow 5 of these patterns. And so now I match, and now I satisfy all of these tests. So now, of course, this won't work anymore if I now add more characters. So if I have 1,273, and that's not a valid IP address. So if I run this, I should get a failing test again. This should be, thanks. This should be now a false. And this will now fail. So then what I can do is I can say, okay, I use these quantifiers that we've learned. So I can say this digit needs to occur between 1 and 3 times. Okay? And now it passes again. Okay, and so then I have 3 minutes left, and I'm just going to show you the results. Let's copy them in here. Oops. So then what we want to do is we also want to constrain that we only allow characters that are between 1 and 255. So the way you could do that is the following. So what you could do is you could specify a character class, and that character class now, that represents numbers between 1 and 255. And what have I done? So this is, it's a group, so because I use that later on, as you will see. And so what I have is I use these vertical colons to represent OR. So vertical colons are alternatives. So the first alternative is that I have a number 2 and a number 5, and then any number between 0 and 5. So this handles everything from 250 to 255. Okay, so this is one valid number. Then I have an alternative case, so I use this vertical colon. And now I'm handling the cases from 200 to 249. So I say I have a number starting with 2, then a digit between 0 and 4, and then a digit between 0 and 9. Okay? And then the final case is that I have the numbers from 1 to 199. And then what I do here is I have either a 0 or 1 that could be or could not be there, right? Because if I have 1 between 1 and 99, I don't have the 100 digit. Then I have the 10th digit, so 0 is 10 to 90. Again, this is optional. And then I have a character class 0 to 9, which has to be there, right? Because we don't allow empty strings. Okay, so then I group this entire thing. So I use the question mark colon to not have a non-referencing group. And then what I've done here is I said that I want to have this character once, and then I created a new group saying I want to have a colon followed by another number, and that totally 3 times. So this here, this will be character that represents the first number, and then afterwards I always have a colon followed by number, colon followed by number, colon followed by number, exactly 3 times. This is what we do here. Okay, that was the most advanced example that I'm going to show.